Let us suppose that we are provided with an algebraic equation x squared minus 4 is equals to 0. Now we have to solve for x, meaning we have to find the value of x for which the given algebraic equation is going to be valid. So we will take the 4 to the right hand side, so we have x squared is equals to 4. Then we take the square root on both sides. So square root of x squared, x being a perfect square, gives us simply x, and square root of 4 will be equals to plus or minus 2. So that means there are two real values of x. So one of the value is positive 2, and when we square it, we get x squared is equals to 4. So that satisfies our algebraic equation. And if we consider x to be equals to negative 2, then squaring both sides, we also get negative 2 squared is equals to 4. So this is also satisfying our algebraic equation. Now things becomes extremely tricky if we replace the negative sign by a positive sign, meaning if we have the equation x squared plus 4 is equals to 0, that gives us x squared is equals to negative 4. Now before even going further, let's think of a number x such that when we square it, we get a negative number. That is not possible because there are no real values of x. Now no matter what number we consider, the squaring that number is never going to give us a negative 4. We have already talked about x being 2 or negative 2. So if we square 2, we get a positive 4, and if we consider x to be equals to negative 2, squaring it gives us also positive 4. So there is no such number which gives us negative 4. Anyway, let's go a little further ahead. We take the square roots of both sides. So we have square root of x squared equals to square root of negative 4. Square root of x squared gives us x, and then we have a square root of plus or minus a square root of negative 4. Now to take care of this negative, so we can either write it as square root of negative 1 times positive 4. Then we can rewrite it as square root of negative 1 times square root of 4. We know that square root of 4 is 2. Then we have plus or minus 2 multiplied to square root of negative 1. Now the problem lies here. We don't know how to deal with the square root of negative 1. So that's why we say there are no real values of x exists. To deal with this problem, the German mathematician Leonhard Euler gave us a value. He said that consider the square root of negative 1 to be a number represented by the symbol I, and it's called iota. Now if we use this definition, then our equation becomes x equals to plus or minus twice of I. Now he's saying that this twice of I, this is not a real value. This is not a real number. And he said that this number belongs to a set called a set of imaginary numbers. Now for the time being, we'll not go into the history behind how this imaginary number concept was introduced, but for the time being we're going to work on some problems so that once we get familiar, then we will delve deeper into the concept of imaginary numbers. So for the time being, we stick to the definition that I is defined as the square root of negative 1, such that when we square both sides, we get I squared is equals to negative 1. So this is the value that we are going to use for the time being and do some numericals based on this problem. Now let us work on some problems based around manipulation of numbers using iota values. So we will be using the value that I sub squared is equals to -1. So using this value, we can find out I cubed. So value of I cubed will be equals to I squared times I. So we know that I squared is equals to -1. So we have -1 times I, and that gives us a negative I. Then we go and find out the value of I raised to the power of 4. So I raised to the power of 4 is I squared times I squared, which is equals to -1 multiplied to -1, and that gives us a +1. To find out the value of I raised to the power of 5, we have I raised to the power of 4 times I, which will be equals to 1 multiplied to I, and that gives us I. Then we have I raised to the power of 6. We can use either I raised to the power of 5 multiplied to I squared multiplied to I, or rather we will use instead I raised to the power of 4 times I squared, which gives us 1 multiplied by -1, that gives us a -1. Then we try to find out the value of I raised to the power of 7, so that will be equals to I raised to the power of 6 times I, which gives us I raised to the power of 6 is -1 multiplied by I, so that gives us -I. I raised to the power of 8, that will be equals to I raised to the power of 4 times I raised to the power of 4, which is equals to 1 multiplied to 1, that will give us 1. And we can continue. Now here we see that when the index of I, or you can say the power of I, is an odd number, 3, 5 and 7, so we are getting negative iota, iota and negative iota respectively. And whenever the power of I is an even number, then we are getting all real numbers. So this means that if we have I raised to the power of n, then it's going to have two values. One is going to give us a real value if n is some even number. So let's call it 2 times m, where m is an integer. If I consider some integer m and multiply it by 2, it becomes an even number, and I raised to the power some even number always gives us a real value, and it's going to give us an imaginary value if n is an odd number. So that means we have an even number and we add 1 to it and it becomes an odd number. Again, m is some integer. So these are the two possibilities. Now using this, let us try to find out the value of 1 divided by I. So we know that the value of 1, this is another standard value that we are going to use over and over again, that I raised to the power of 4 is going to be equals to 1. So we have 1 divided by I. So we know that 1 is I raised to the power of 4 divided by I. So that gives us I cubed. And we know that our I cube value is -1. So we have negative I cube is negative I. So 1 over I is equivalent to -I. Then we can find out the value of I raised to the power of 7. So we can use I to the power 4 squared, because I raised to the power 4 whole squared is I raised to the power of 8 divided by I raised to the power of 7. So we have I raised to the power of 8 divided by I raised to the power of 7, which is equals to I raised to the power of 8 minus 7, and that simply gives us I. And what about I raised to the power of 321? What will be the value of this? So first we are going to consider the number 321 and divide it by 4. So we have 4 times 8 is 32, which leaves us with remainder 1 and 0. So we have 321 can be written as 4 times 80, which gives us 320, and the remainder 1. So that means we can rewrite I raised to the power 321 as 4 times 380 plus 1. So this can be also written as I raised to the power 4 times 80 times I, and I raised to the power 40 whole raised to the power of 80 times I. I raised to the power of 4 is 1. We have 1 raised to the power of 80 times I. So that gives us simply 1 multiplied to I, and the final answer is I. Let us do a few more problems based on the definition of iota. Let's say we are given with I raised to the power of 137. So we will take the number 137 and divide it by 4. So that gives us 4 times 2 is 12, and we have 17. So 4 times 4 is 16 with a remainder of 1. So that means we can write the number 117 as 4 times 24 plus the remainder 1. So let's rewrite it. So we have I raised to the power of 4 times 24 plus 1. This could be rewritten as I raised to the power of 4 times 24 times I raised to the power of 1, and then we have I raised to the power of 4 whole raised to the power of 24 times I. We know that I raised to the power of 4 is 1, and 1 raised to the power of 24 is also going to give us 1, and the final answer will be equals to I. So this is the value of I raised to the power of 137. Let's say we have y raised to the power negative 999. So this can be rewritten as 1 over I raised to the power of 999. Now let us divide 999 by 4. So we have 4. 4 times 2 is 8. This is 19. 4 times 4 is 16. We have 3. The 9 comes. And then we have 4 times 9 is 36, which leaves us with a remainder of 3. So that means we can rewrite I raised to the power 999 as 4 times 249 plus 3. So this will be equals to 1 divided by I raised to the power of 4 whole raised to the power of 249 times I cube. So this value is going to be simply 1 because I raised to the power 4 is 1. So we are left with 1 over I cube. And we know that y on 1 is I raised to the power 4. So I raised to the power 4 divided by I cube is going to give us I. So in this question we are given negative square root of negative 1 raised to the power of 4n plus 5, where n is a natural number. So this can be rewritten as minus, so square root of minus 1 is simply iota raised to the power of 4n plus 5. Now minus of I can be written as minus of 1 times I raised to the power of 4n plus 5. That can be written as negative 1 raised to the power of 4n plus 5 times I raised to the power 4n plus 5, which will be equals to negative 1 raised to the power 4n times negative 1 raised to the power of 5 times I raised to the power of 4n times I raised to the power of 5. Then we have negative 1 raised to the power of 4 whole raised to the power of n. Negative 1 raised to the power of 5 is simply going to be negative 1, and we have I raised to the power of 4 raised to the power of n, and I raised to the power of 5 will be simply I raised to the power of 4 times I. So we have negative 1 raised to the power of 4, which is going to be positive 1, and 1 raised to the power of n is going to be simply 1. So we have 1 multiplied to negative 1. I raised to the power of 4 is 1. 1 raised to the power of n is going to be 1. And we have I raised to the power of 4, which is 1. 1 times I is going to give us I. So the final answer is going to be equals to minus of I.